5s. Welcome to your natural science lesson. In today's lesson, we're going to be looking at safety with electricity. So in the past few lessons, we've been looking at what electricity is, what do we use electricity for, and anything electricity related. So in this lesson, we're going to be looking at safety with electricity specifically. Okay, does anybody know what the word safety means? Yes.
Staying away from dangerous stuff.
Staying away from dangerous stuff. True, right? So staying away from electricity, or being safe around electricity. You can also use the word secure. So security with electricity, right? So I'm going to give you a few keywords that we're going to be talking about, right? So first we're going to look at naked wires. What is a naked wire? Naked. Okay, fine. So a naked wire is a wire that doesn't have that plastic on top of it, right? So looking at this cable right here, it has a plastic on top of it, but it's formally called PVC, right? It's a PVC plastic on top of this wire that's inside. PVC doesn't really matter, but it's just information that I'm sharing with you guys. So this wire has PVC on top of it because PVC is an insulator. We all remember what an insulator is, right? What is an insulator?
It's a, you can call it a wire, or it's a plastic that doesn't allow electricity to pass through.
Good. Something that doesn't allow electricity to pass through it. So this plastic is insulator for the copper inside. Okay. So next we're going to look at the picture in front of you. Okay. So this picture, right? This picture has multiple unsafe electrical connections. So I want you to point out some of the unsafe connections and tell me what you see and tell me what you think might happen if those things were connected, or those are wires that have current passing through them. Okay. So what's the first thing you see?
The wires inside the dog's mouth.
The dog is eating the wire. What will happen to the dog? What do you think might happen to the dog?
Electric shock.
An electric shock. Good. What's next?
The girl is holding the lamp.
The girl is holding the lamp. What will happen to that girl?
Shock too.
Also a shock. Also a burn, because remember the bulb is quite hot. So that would also happen. What else do we see?
The water is on top of the electric television.
On top of the water on top of the television. What is wrong with that? Why is having water on top of it, an electrical appliance, wrong? What would happen?
The water may spill in electricity first.
Yes, the water might spill and a whole electric shock might happen. What else do we see in the picture?
Also a candlelight.
Candlelight. What's wrong with that?
Can turn to liquid and then same happens with water.
Maybe, yes. What else?
There are a lot of plugs on the electric circuit.
A lot of plugs on one electric socket. What might happen?
Electric shock again.
Also electric shock. So you can see in the picture that the boy is next to the socket. His appliances are also attached to that same multi-plug socket. So his appliances might also burst into flames and get ruined pretty much, right? So, so like we said, the boy's appliances might also burst. That's also hurting him in the process, right? So now I want you to look at the appliances that are in the picture, right? And think about appliances in your own home, electrical appliances in your own home. I want you to list some electrical appliances in your own home. Okay. So think quickly, electrical appliances in your own home. Right? So first. Okay. Electrical appliance number 1. What do you have at home?
Television.
We have televisions at our homes. What else? Kettles. Yes. What else? Washing machine. Yes, washer. What else? Stoves. Good. So I want to give you a little instance with these appliances. What would happen if you had a plugged kettle, right? Here's your plugged kettle next to your stove, right? And it's on, it's boiling, and it's next to your stove, and while it's boiling, it tips over. What do you think is going to happen in this scenario? What's going to happen?
The electricity will burst.
Maybe. Okay. That is also a possibility. What else might happen? The electricity might burst. What else might happen? Think about it. The kettle is boiling. Obviously, when a kettle boils, it shakes a bit. What do you think might happen? If it's too close to the stove, your stove is on, the kettle is boiling, what might happen?
If the kettle is plastic, the stove might melt.
Very good.
With the kettle.
Yes. Please pause that. Okay, so now we're gonna look at these appliances that you guys listed. Okay, so I want you to think about this scenario. A kettle is boiling, right? This is my kettle. I'm a horrible grower, so excuse me. A kettle is boiling and there's a stove that's on right next to the kettle, right? So it's boiling, and they're like near the same socket, right? The plugs and the appliances are plugged into the same socket and all of that. The kettle is now boiling. What do you think might happen? Think about it quickly. So a kettle is boiling, and obviously we know that when a kettle is boiling, it sometimes shakes a bit, and then it's right next to a plugged stove. All of these plates are on. Your stove is on high heat, your kettle is boiling. What might happen?
The kettle the water from the kettle might go inside the socket.
Yes. Scenario number one. Water from the kettle might go inside the socket. What might happen? What would happen next?
If the socket is not protected, like doesn't have the plastic,
Which is PVC. Remember we spoke about it. PVC. Yes.
is the socket might burst.
Very good. So if the water goes inside the socket itself might blow up, right? There might be an electrical shock happening right there. Okay, what else might happen? So that's our first instance. The socket and the kettle on their own, something might happen. What else might happen?
Since the kettle is close to the stove, the heat from the stove might melt. The kettle, if it's plastic, the liquid might go to the stove.
Very good. That's a very good. So the stove might melt the kettle the water in the kettle might just get out and just cause a whole problem here, right? So there's one more thing that might happen here. One more thing. So the kettle and the socket is our first instance. The kettle and the stove is our second one. What's the third one? What else might happen here? Okay, so I think, remember our sockets and the stove are close together. So the plug that connects the stove and the kettle might get burned. It might burn, and that would cause an electrical shortage in this whole thing. Oh, yes. Okay, so that is what might happen. So since we've spoken about all of this, what might happen in our homes with the appliances we have at home, I want us to make a clearer list, right? a clear list, and this is going to be used for another activity that I'm going to ask you to do. So we've spoken about the don'ts, what we don't do, right? So I want us to make a clear list of everything we've discussed, okay? So don't with electricity, right? Don't with electricity. What is the first thing we shouldn't do?
Play around electricity.
We don't play around electricity. Yes. What else?
Don't use electricity without your elders.
Very good. Don't use electricity without supervision. Right? What else? Number 3. Let's try to get to 5 at least of things we shouldn't do. Let me give you at least 1. Don't put your fingers in sockets. Okay? Don't put your fingers in sockets. What might happen? What do you think if your little sister, your little brother just goes up to a socket and puts her little finger or his little finger in the socket? What might happen?
Get electric shock.
An electric shock. Imagine that baby. Poor baby with an electric shock. No fingers in electrical sockets. Right? Number 4. Do not put electrical appliances near liquids. Right? We don't put electrical appliances near liquids. Thinking about that. Okay, so number 4 we said don't put electrical appliances near water. Right? So for like a practical example, I want to show you something. So I want you to look at this. What's this?
Hair dryer.
This is a hair dryer. And in here, in this little bucket, I have water, right? So this is not a plugged hair dryer, right? What do you think will happen if I take this hair dryer, unplugged as it is, and put it in the water? What might happen? Nothing will happen. Why won't anything happen? Why do you think nothing will happen? Why won't anything happen?
Because the hair dryer is not connected to electricity.
Very good. It's not connected. There's no electricity passing through it. But I take this afterwards, rather. Think about this scenario. I take this hair dryer, plug it in the same, and take the same water and put the hair dryer in the water. What might happen? To me, I have the hair dryer in my hand, it's plugged, and I mistakenly just drop it into the water. What is going to happen?
You will get an electric shock.
I will definitely get an electric shock. Very good. Thank you. That means you guys are understanding. Okay, the last one. What don't we do?
Play with the switches connected to the circuit.
Play with switches. Yes, we do not play with switches, right? Don't play with switches. Why? Why don't you play with switches? Why don't you just walk up to each and every switch you like and just play with it? Why not?
Because it's connected to the circuit.
Because it's connected, that is one reason. Also another reason is that you might create an electrical failure. There might be an electrical failure and you might blow everything in the house up just by playing with one socket. Remember, our electricity is connected throughout the house, so you play with one thing and it might affect something else. Okay, so we've done the don'ts. Yeah? While I raise the board, please think about the do's. What do we do around electricity or with electrical appliances? What do we do around electricity or with electrical appliances? Quickly think about that, and if So now, excuse me, now do's, right? We're doing the do's. What do we do with electricity? Things you can do with electricity, with electrical appliances.
You can watch TV.
You can watch. But I want safety. I want you to think safety. Do's around electrical appliances.
What you can do around.
Yes. So let me just give you one. Things to do. Ask for permission for using an electrical appliance, right? Pause. Okay, so we said ask for permission when using electrical appliances, right? So number 2, what else?
Hold the plastic when unplugging the appliance.
Very good. So hold the plastic, the PVC, instead of the metal part, right? Okay. That's very good. Hold the plastic and not the metal. What else? Number 3. Let's try to get to 5 also with this one.
Turn off electrical appliances when not necessary.
Very good. Turn off appliances when they're not in use, right? Turn off appliances that are not being used. What else?
Use electricity around others.
Use electric. But that sounds the same as asking for permission. Using electrical appliances near adults. That is asking for permission. Let's try finding something else.
That's asking for permission. We are not doing.
Okay. I think number 4 would be don't play near power stations or power lines. See those wires and cords outside of your homes? Do not play near those things. Don't play with kites near them. Don't throw balls at them. Excuse me. Just don't play near those cords because they have a very high voltage. Okay, they have a lot of electricity flowing through them. So let me write that down. Do not play near them. Okay, what else? Do's with electricity.
Do not climb electrical poles.
Stop. I think we're doing the don't again. We're doing that thing. Number 5. What's the last thing we must do?
Adults should clean electrical appliances often.
Very good. So adults must clean their electrical appliances often, right? So clean electrical appliances often. You clean them often. What do you think might happen if they're not cleaned often? So think about your stove. You see, you cook on stoves. There's always greasy stuff on stove. And imagine if you use your stove over and over and over again and you don't clean it. What might happen?
The dirt might go inside the circuit.
The dirt might go inside the socket. Very good. Dirt inside the socket, which might cause an electrical failure. What else might happen? You know what else might happen? Let me just tell you what else might happen. So since your stove has grease on it, grease is flammable, right? So if your stove gets too hot and it's not clean, it might catch fire. That is what might happen. And if your stove catches fire and nobody's there, noticing that the stove is on fire, then your whole house might burn down. And we definitely don't want that, right? Okay, so now I wanted to go over these things again. Do's around electricity. What's the first one?
Ask for permission when you want to use electrical appliances.
Very good. Ask for permission when you want to use electrical appliances. Number 2, what's the next one?
plastic when unplugging electrical appliance.
Very good. You hold the plastic and not the actual metal, right? We don't want you to get burned or have an unexpected electrical shock. Number 3, what else must we do?
Turn off appliances that are not necessary.
Turn off appliances that are not being used, that are unnecessary, right? Okay, this one. What's the next one?
Clean appliances.
We
often.
clean appliances often. Okay, that's the do's, right? So we've discussed all of this, the do's, the don'ts around electricity, which is going to take us to our next activity, right? Because we've done this together. Let me quickly erase this, and it's going to take us to our next, what must be next. Okay. So this part is going to take us to our next activity. But before we go into this, I want you to remind me of some of the keywords we've used and see if you've actually been listening. Remember we spoke about a naked wire. Yes. Who remembers what a naked wire is? Yes, what's a naked wire?
A wire that doesn't have PVC.
Very good. Wire that does not have PVC, right?
Plastic.
What do we call wire that has PVC? You think we call it closed wire? Could be, but we don't call it a closed wire because now it has PVC. It's actually just wire, a protected wire, because the wire is actually inside, right? So we call it a protected wire. It is protected. When it's naked, it doesn't have any PVC, right? And another word we discussed in the beginning of our lesson is safety. Who remembers what safety means? Yes.
Insecure.
Security, very good. And then we also spoke briefly, and we've spoken about this in our other lessons, an insulator. What does an insulator mean?
If the electricity can't go through plastic or anything that's surrounding.
Very good. When electricity cannot pass through an object, right? So let me just ask you this. We've done this in our other one. What is a conductor? What is something that conducts?
Conductor is more like a wire, or it's a wire that conducts electricity.
A conductor is a wire that conducts electricity. But something that allows electricity to pass through it. Okay, alright. So now we've done that. So I see you've been listening and you know all the keywords. So these are going to be important just now. So what we're going to do now is the activity that I expect from you guys. So now I want you to go back to the picture we talked about in the beginning. The picture we discussed in the beginning. Just quickly go back to that picture. So you can see that that picture shows you a lot of unsafe connections, and it shows you a girl touching a pal. We've discussed all of those things. So in this activity that we're going to do, I want you to take I'm going to give you A2 paper, right? You're going to take some A2 paper and design a poster on safety with electricity, right? We're going to do a poster with safety electricity. But before that, I actually forgot a very important thing. When you see, I want to ask you this question. When you see unsafe connections, or you see a problem, or you have a problem with your electrical appliances or your electrical connections in the home, who do you call? Who do you call?
Your parents.
Your parents, yes. Your mom and dad, and tell them that there's something wrong. And who do you think they call?
The police.
The police. You could call the police and tell them that your house is about to blow up. Yes. But who deals with electricity specifically? Whose job is it to make sure that the country's electricity is protected and the people are safe around these things? Whose job is it? Think about this person. They're always in the media about their electrical connections, about their substations. Who's in charge of this?
Electricians.
Electricians, but who do the electricians work for?
Eskom.
ESCOM. That is what we're looking for. ESCOM. So ESCOM is the person your mom and dad calls when they have electrical problems, when there's a substation that just blew up, or a meter box or something that just blew up that is electricity connected. You call them and they will come fix it for you. Okay, it is their job to fix it for you. Like it's my job to tell you about it, it's their job to fix it. Okay, so I just want to write down the numbers, and then I want these in this next activity. Okay, so in this activity that I expect you to do, that I was talking about, I want you to list the do's and don'ts around electricity. Remember, we listed all of those things. So you can draw, you can put pictures, you can do whatever you want, but your poster must tell me that this is what we do around electricity, this is what we don't do around electricity, and this is who to call when you have problems. The chain of command. That is what we're supposed to be doing right now. Okay? Yes. So, okay, so everybody hopefully understands the instructions, and if you need help, please just come ask me. But before we even conclude the lesson, I want you to go back to everything we've done. Right? Everything we've done. Do you have any questions? Do you have any queries? Do you have like anything to point out? Is there anything you want us to go back to quickly? Or was everything just fine and you good? Yes.
What happens if one household has a lot of plants?
If one household has a lot of unsafe plugs, is that what you're trying to say? Or just plugs laying around? Just plugs. Are they connected? Are they connected? Well, if a house has like a lot of plugs, they might cause an electrical shortage or an electrical overload, and then the boxes inside the house. Have you guys noticed those little boxes in the house? Those things might blow up. You might trip your switch and it might blow up. Okay, so if anybody doesn't have any other questions, yeah, no? Okay, so since nobody has any questions, that will be the conclusion of our lesson. So thank you for listening, guys, and posters be ready. Okay, thank you.